Hello, and welcome to Physics at Night. I am so glad you have found this quiet frequency. The day is over. The maps we use to navigate our busy lives, the schedules, the emails, the traffic routes, are folded up and put away. Now, we are left with the territory of the dark. We are left with the open sky and the ceiling above your bed. Tonight, we are going to go on a journey to the farthest place imaginable. We're going to travel past the moon, past the sun, past the swirling arms of the Milky Way. We're going to keep walking until we run out of stars, and we're going to ask the question that humans have whispered since we first looked up at the dome of the night. Is there a wall? Does the universe have an end? If you travel far enough, do you eventually hit a barrier, a sign that says stop? Or does it go on forever? And if it does, how can our minds possibly hold something that has no limit? We're going to explore the geometry of the infinite. We will talk about curved mirrors, endless oceans, and the strange realization that the center of the universe is exactly where you're lying right now. But before we step off the map, I have a small request. If you find comfort in these nightly journeys, please consider leaving a gentle like to help this signal travel a little further into the algorithm. And tonight, I want to try something different in the comments. Instead of just telling me where you are, I want you to tell me about your horizon. When you look out your window tonight, what is the very last thing you can see? Is it a street light down the road, a distant mountain, or just the reflection of your own room in the glass? Let's build a collection of horizons from around the world, a map of our edges. As always, this story is for relaxation and wonder. It is not medical advice. It is simply a way to untie the knots of the day and let the mind drift. So, close your eyes, picture the horizon, imagine a ship, sailing toward it and never falling off. Let's begin. Let's begin by looking at the room you are in right now. I want you to become aware of the space around you. Look at the wall across from your bed, or the ceiling above you. That wall is a boundary. It defines the limits of your room. If you were to walk toward it, you would eventually touch it. You would stop. To go further, you would have to open a door or break through the plaster, and if you did that, you would find yourself in another room, or outside in the street. We live our entire lives defined by these containers. We are born in rooms, we learn in rooms, we sleep in rooms. We understand the concept of inside and outside instinctively. Inside the cup is coffee, outside the cup is air, inside the city is noise, outside the city is countryside. So, when we turn our minds to the biggest container of all, the universe, we bring these habits with us. We assume that the universe must be like a room. It must have a size, it must have a shape, and most importantly, it must have walls. I want you to perform a thought experiment with me. It is a simple journey, but it has driven philosophers crazy for 2,000 years. Imagine you are an archer. You are the Roman poet Lucretius, standing on the very edge of the universe. Let's assume for a moment that there is an edge. Let's assume you have travelled past all the stars, past all the galaxies, and you have reached the final boundary. Maybe it looks like a giant dark wall. Maybe it looks like a shimmering curtain of energy. But there it is, the end. You stand on the precipice, you lift your bow, you notch an arrow, and you fire it. You shoot the arrow directly at the wall. What happens? Lucretius asked this question in the 1st century BC. He saw only two possibilities. Possibility 1. The arrow hits the wall and bounces back. If this happens, then the wall is matter. The wall is stuff. And if the wall is stuff, Then it must be part of the universe you haven't found. The edge of the universe. You have just found a large fence inside the universe. So you must climb over the fence, and once you are on the other side, you shoot another arrow. Possibility 2. The arrow punches through the wall and keeps flying. If this happens, then the wall wasn't really an edge. It was just a curtain. The arrow is now flying into new space. It is flying into the outside. But if space exists outside the wall, then the outside is really just more inside. Space is space. So you must follow the arrow and shoot again. Lucretius concluded that you can never truly stop. If you hit a barrier, it's matter, part of the universe. If you pass through, it's space, part of the universe. Therefore, the universe must be infinite. This logic feels sound. It feels impossible to argue with. How can you have an edge if there is nothing on the other side? And if there is nothing on the other side, isn't nothing just empty space? But our human brains struggle with this. We hate the infinite. The idea of a universe that goes on forever, without end, is terrifying. It makes us feel like we are falling into a bottomless pit. We crave closure. We want the story to have a final page. So, throughout history, we tried to build cages for the cosmos. Aristotle believed the universe was a series of nesting crystal spheres. The Earth was in the middle, then the moon, then the sun, then the stars, and outside the final sphere of stars, there was no space, there was no time, there was only the spiritual realm, the prime mover. The universe was a cozy finite geode, a jewellery box. This view comforted us for a long time. It gave us a centre. It gave us a limit. It told us, you're here, the wall is there, you're safe. But then, we invented the telescope. We looked through the glass, and the crystal spheres shattered. We saw that the stars were not painted on a ceiling. They were deep. Some were close, some were far, and behind the far ones were fainter ones, and behind those were clouds of light that turned out to be entire other galaxies. The walls fell down. The universe expanded in our minds from a jewellery box to a cathedral, to an ocean, to an abyss, and tonight we are floating in that abyss. We are trying to find our footing. We ask the question again, is there an edge? But now we have to ask it with more nuance, because edge can mean two things. Meaning one, a temporal edge. An edge in time. Did the universe start? Will it end? If you walk backward in time, do you hit a wall called the Big Bang? The answer to this is seemingly yes, but we will get to that. Meaning two, a spatial edge. An edge in geometry. If you fly a rocket ship in one direction, do you run out of road? This is the one that keeps us awake, because if there is no road, what is there? The ancients used to write on their maps, "Here there be dragons." At the edge of the known world, the maps just stopped. The ink faded into the parchment. Is the universe like that parchment? Does reality just fade out? Do the laws of physics get tired and stop working? Does 2 + 2 stop equaling 4? Or is the universe like a video game? Think about Pac-Man. When Pac-Man goes off the right side of the screen, he doesn't hit a wall. He doesn't fall into the void. He instantly reappears on the left side of the screen. The screen is flat. It has edges, but the logic of the game connects the edges together. The game world is finite. It fits on a screen. But it is unbounded. You can run forever. Could our universe be a 3D Pac-Man game? Could we fly straight for 1 trillion years, past the edge, and suddenly find ourselves back at Earth, approaching from the other side? It sounds like science fiction, but it is a very real possibility in topology. A toroidal universe, a donut shape. Imagine the comfort of that. It would mean the universe is not infinite. It is not a bottomless pit. It has a specific size. It is a closed loop, but it has no walls, no barriers, no scary drop-offs. It is a perfect, seamless, self-contained jewel, just like the Earth is a self-contained sphere. But before we can test that theory, before we can launch our imaginary rocket, we have to deal with a practical problem, a problem of vision. We're not gods looking down at the universe from the outside. We are ants living inside the anthill, and we have very bad eyes. We can only see as far as light has travelled. We are trapped in a bubble of information. So when we ask, does the universe have an edge? We have to be careful. Are we asking about the edge of reality, or are we asking about the edge of vision? Because there is an edge out there, a hard, absolute edge that we can see with our telescopes. It is a wall of fire. It surrounds us on all sides. It is called the cosmic microwave background. It looks like a wall. It acts like a wall. We cannot see past it. But is it the end of the universe, or is it just the end of the show? In the next chapter, we're going to define our terms. We're going to distinguish between the observable universe, the bubble, and the global universe, the ocean. We're going to learn that we are like sailors in the middle of the sea surrounded by fog. The fog has an edge, but the ocean might go on forever. So, let the walls of your room dissolve. Let the ceiling fade away. You're floating in the dark, and the only light is the distant, ancient glow of the beginning of time. We stood on the imaginary edge of reality. We fired an arrow into the void and watched it fly forever. We confronted the fear of the infinite and the comfort of the closed loop. But before we can explore the true shape of the cosmos, we have to solve a language problem. Words are tricky things. They are small containers that we try to stuff big ideas into. And the word universe is the biggest container of all. When you hear the word universe, what do you picture? Do you picture a black box filled with stars? Do you picture everything that exists? Do you picture God? Do you picture a multiverse? In physics, the word is slippery, because there are actually two universes. There is the little universe, the one we can see, and there is the big universe, the one that actually exists. Tonight, we're going to learn the difference. We're going to learn that we're living in a trap, not a malicious trap, a trap of light. I want you to imagine you are a sailor. You are floating on a vast, endless ocean in the middle of the night. You have a lantern on your mast. The lantern casts a circle of light around your boat. Let's say the light reaches for 1 mile in every direction. Inside that circle, you can see everything. You can see waves. You can see fish. You can see drifting wood. You can map this territory perfectly. This is your observable ocean. But does the ocean stop at the edge of the light? Of course not. You know, intellectually, that the water continues into the darkness. You know there are other waves, other fish, maybe even other boats out there in the gloom, but you cannot prove it. You cannot measure it. You cannot map it. Those things belong to the global ocean. We are that sailor. The Earth is our boat, and the lantern is the age of the universe. This brings us to the concept of the cosmic horizon. Here is the one fact that rules astronomy. Light takes time to travel. It is fast, 186,000 miles per second, but it is not instant. When you look at the moon, you are seeing it as it was 1.3 seconds ago. When you look at the Sun, you're seeing it as it was 8 minutes ago. When you look at the Andromeda Galaxy, you are seeing it as it was 2.5 million years ago. Looking out into space is looking back into time. The deeper you look, the older the image. Now, we know, and we'll talk about this more later, that the universe had a beginning, the Big Bang. It happened roughly 13.8 billion years ago. This means that the lantern has only been turned on for 13.8 billion years. So, if we look out into the dark, we can only see objects whose light has had enough time to reach us. If a star is 5 billion light years away, its light has had plenty of time to get here. We see it. If a star is 10 billion light years away, we see it. But if a star is 50 billion light years away, its light is still on the way. It is rushing toward us through the void. But it hasn't arrived yet. It is. Outside our lantern circle, this creates a hard, spherical border around the Earth. We call it the observable universe. Imagine a giant bubble with Earth in the exact center. The radius of this bubble is about 46 billion light years. Wait, why 46? If the universe is only 13.8 billion years old, shouldn't the radius be 13.8? We'll explain that expansion trick in a later chapter. For now, just accept the bubble is huge. Inside this bubble, there are 2 trillion galaxies. There are sextillions of stars. There are black holes, nebulas, planets, and maybe civilizations. Everything we have ever seen, measured, or named is inside this bubble. But here is the humbling part. Is the edge of the bubble the edge of reality? Imagine you are an ant living in Times Square, New York City. You can see the buildings around you. You can see the billboards, but you cannot see Tokyo. Does Tokyo exist? Yes. But to you, it is theoretical. It is beyond your horizon. Most cosmologists believe that the global universe, the part outside our bubble, is much, much larger than the part inside. Some theories suggest it is infinite. Other theories suggest it is just really, really big. Maybe 250 times bigger than our bubble. Maybe 1 billion times bigger. If this is true, then our observable universe is just a tiny patch of skin on a giant beast. We're looking at a microscopic sample of reality and trying to guess the shape of the whole animal. This leads to a strange realization about centers. People often ask, where is the center of the universe? And the answer is, you are. Not metaphorically, literally. Because the observable universe is defined by your line of sight. You're always in the middle of it. If you move to Mars, the bubble moves with you. You gain a little bit of new universe on one side and lose a little bit on the other. If you teleported to a galaxy 1 billion light years away, you would be in the center of your own bubble. You would see galaxies that we can't see, and we would see galaxies that you can't see. We're all walking around in our own private spheres of visibility, overlapping circles of light on a dark ocean. So, when we ask, does the universe have an edge? We have to be very careful. The observable universe definitely has an edge. We can see it. We can take a picture of it. It is the surface of last scattering, the cosmic microwave background. It is the wall of fog where the universe becomes opaque because we're looking so far back in time that we are seeing the primordial fire of the Big Bang. But the global universe, the whole enchilada, that is the mystery. If you could freeze time and fly past that wall of fog, what would you find? Would you find dragons? Would you find nothing? Or would you just find more galaxies? Think about the principle of mediocrity. This is a guiding rule in science. It says, you are not special. Earth is not the centre of the solar system. Copernicus taught us that. The sun is not the centre of the galaxy. The galaxy is not the centre of the universe. So, if we are not special, why would the universe stop just because we can't see it? Why would the edge of our vision happen to line up with the edge of reality? That would be a coincidence of epic proportions. It is much more likely that the ocean continues, that past the horizon there are just more waves, more stars, more darkness, more silence. But does it go on forever? Or does it eventually wrap around? Is the global universe a flat sheet that extends to infinity? Or is it a giant sphere, a hypersphere that is finite but unbounded? Tonight we don't have to answer that. We just have to accept the limits of our eyes. We have to accept that we are the sailor with the lantern. We are safe in our circle of light. We have mapped the waters around our boat. But out there, in the deep dark, the universe is keeping its secrets. So, as you lie in bed, visualize the bubble. Visualize the sphere of stars surrounding Earth. It is a huge room. A room 93 billion light-years wide. It is plenty of space for us. We will never explore it all. We will never touch the walls. For all practical purposes, we are free. But the mind wants to know what lies beyond. The mind wants to know about the total universe. In the next chapter, we're going to look at why the universe looks the way it does. We're going to talk about the darkness of the night sky. Have you ever wondered why the sky is black? If the universe is infinite and full of infinite stars, shouldn't the sky be blindingly white? Every line of sight should end on a star. The fact that it is dark tells us something profound about the edge. It is called Olber's paradox, and it is the first clue that the universe is not what it seems. So, rest in the centre of your bubble. You are the captain of the observable world. Everything you see is yours. In the last chapter, we defined our terms. We drew a circle around our boat in the middle of the dark ocean. We learned that the observable universe is just the part of the water illuminated by our lantern, and we learned that the lantern has only been turned on for 13.8 billion years. But tonight, I want to ask you a question that sounds simple. It is a question you probably asked when you were 5 years old, and your parents probably gave you a simple answer. But the simple answer is wrong. The question is, why is the sky dark at night? You might say, because the sun went down. And yes, that explains why it isn't daytime. But it doesn't explain why the night sky is black. Think about it. In the last chapter, we discussed the possibility that the global universe is infinite, or at least incredibly vast. If the universe goes on forever, and if it is filled with stars, then in every single direction you look, your line of sight should eventually hit a star. Imagine you're standing in the middle of a dense forest. If the forest is small, you can see gaps between the trees. You can see the sky outside. But if the forest is infinite, if the trees go on forever in every direction, then no matter where you look, your eye will hit bark. Every gap between the nearby trees will be filled by a slightly more distant tree, and every gap between those will be filled by a very distant tree. The entire horizon would be a solid wall of wood. Now, replace the trees with stars. If the universe is infinite and eternal and static, then every point on the night sky should be occupied by a star. The sky shouldn't be black. It should be blindingly white. It should be as bright as the surface of the sun, everywhere, all the time. We shouldn't have a night. We should be cooked inside a cosmic oven. This is called Olbers' paradox. Named after Heinrich Olbers, a German astronomer who pointed it out in the 1800s, though he wasn't the first to notice it. Kepler noticed it too. The fact that the sky is dark is a massive clue. It is a whisper from the cosmos telling us something profound about its structure. It tells us that the universe is not what it seems. There are two ways to solve this paradox, two ways to make the sky black. Solution 1. The universe has an edge. If the forest stops, you see the gaps. If the stars stop, you see the black void beyond them. For a long time, people thought this was the answer. They thought we lived in an island universe, a cluster of stars floating in an infinite empty ocean. The sky was black because we were looking at the emptiness. But we know now that galaxies extend in every direction as far as we can see. The forest doesn't seem to stop, so why is it dark? Solution 2. The universe had a beginning. This is the real answer. The forest might be infinite in space, but it is finite in time. We're back to the speed of light, because light takes time to travel. We can only see stars that are close enough for their light to have reached us since the Big Bang. There might be an infinite number of stars out there. There might be a wall of fire in every direction, but the light from the distant ones simply hasn't arrived yet. It is still rushing through the void, halfway to Earth. The dark patches in the night sky are not empty space. They are not yet. They are places where a star exists, probably, but the news of its existence is still in the mail. So, the universe looks finite to us because it had a birthday. The darkness of the night sky is direct evidence of the Big Bang. If the universe had existed forever, the sky would be fire. The fact that it is black means we are living in a young universe, a universe that is still waking up. But there is a twist. There is actually a third reason the sky is dark, and it has to do with colour. I want you to imagine the early universe again, right after the Big Bang. The universe was hot. It wasn't full of stars. It was full of glowing gas, plasma. It was a wall of fire. If you could have looked around back then, 380,000 years after the start, the entire sky was bright white. It was blinding. So, where did that light go? That light is still travelling. It is still filling the universe. In fact, if you look at the dark patches of the sky with a special telescope, they aren't dark at all. They are glowing. But they aren't glowing in visible light. They're glowing in microwaves. Why? Because the universe is expanding. We will cover this deeply in the next chapter, but we need it here for the paradox. Imagine a wave of light leaving a distant fire. It starts as blue light. High energy, tight, short waves. It travels toward Earth for billions of years, but while it is travelling, the space underneath it is stretching. The road is getting longer, and because the road stretches, the wave stretches too. It gets pulled apart. The wavelength gets longer. Blue becomes red. Red becomes infrared. Infrared becomes microwave. Microwave becomes radio. This is called cosmological redshift. It is the universe cooling down the light. So, the wall of fire that Olbers worried about actually exists. If we had eyes that could see microwaves, the night sky would be blindingly bright. We would see the glowing afterglow of the Big Bang covering every inch of the sky. There would be no night. But because the universe has expanded so much that fire has been cooled down to a gentle hum, it is 2.7 degrees above absolute zero. It is the cosmic microwave background. So, why does the universe look finite? Why do we feel like we're in a bubble? 1. Finite time. We can only see the light that has had time to reach us. 2. Redshift. The light from the furthest edge has been stretched until it is invisible to our human eyes. This creates a horizon. But I want you to understand the nature of this. Horizon. It is not a physical barrier. It is not a cliff. Think about a ship at sea again. The sailor sees the horizon 3 miles away. If he sails toward it, does he hit it? No. The horizon moves. It stays 3 miles away. The horizon is not a feature of the ocean. It is a feature of the observer. The cosmic horizon is the same. It is the distance at which the recession velocity of the universe, the expansion, and the speed of light create a limit to information. But here is the haunting part. The horizon is moving. As time passes, light from further away has time to reach us. Tomorrow, we will be able to see one light day further than we can see today. The bubble is growing. We are constantly unlocking new parts of the universe. New galaxies are coming into view in theory. However, because of dark energy, the acceleration of the universe, the expansion is speeding up. Galaxies near the edge are being pushed away faster than light. Wait, nothing can travel faster than light? Objects can't move through space faster than light, but space itself can expand faster than light. There is no speed limit for the stage, only for the actors. So, there are galaxies on the edge of our vision right now that are sending light toward us. But the space between us is growing so fast that the light is being dragged backward, like a runner on a treadmill that is going too fast. The light will never reach us. Those galaxies are disappearing. They are falling off the edge of the observable world. This gives us a sense of claustrophobia. We're in a bubble. The bubble is growing in time, but the stuff inside the bubble is rushing toward the walls in space. So, does the universe have an edge? To our eyes? Yes. The edge is the oldest light in the universe. It is the baby picture of the cosmos. We're inside a sphere of baby pictures. Every direction we look back in time until we hit the wall of fog that existed 13.8 billion years ago. We are trapped in the center of history. But what lies beyond the fog? If we could teleport instantly to a galaxy on the edge of our vision, what would we see? Would we see the end? No. We would see a new horizon. We would see galaxies that Earth has never seen. We would see a new sky with new stars and a new wall of fog further out. We would realize that the universe is a series of overlapping bubbles, and we're just passing the lantern from one sailor to another. So, tonight, when you close your eyes, visualize the dark sky, but don't see it as empty, see it as quiet. The darkness is a gift. It protects us from the infinite fire of the Big Bang. It gives us a cool, quiet place to sleep. The expansion of the universe has turned down the dimmer switch. We are sleeping in the shadow of the beginning. But this brings us to the mechanism itself. We keep talking about expansion. We keep saying space is stretching, but what does that mean? Is the universe expanding into something? If the balloon is getting bigger, what is outside the balloon? This is the most common question I get. If the universe is everything, how can it get bigger? In the next chapter, we're going to dismantle the idea of inside and outside completely. We're going to learn how to visualize expansion without a center and without an edge. We're going to learn the difference between an explosion, which happens in space, and expansion, which is space. So, rest in the bubble. You're safe in the center of your own observable reality. The light from the edge is watching over you. We looked at the night sky and asked why it was dark. We learned that the darkness is a result of the universe cooling down and stretching out. We introduced the idea that the universe is getting bigger, but tonight, we have to confront the hardest idea in cosmology. It is an idea that breaks our intuition completely. It is the idea of metric expansion. When I say the universe is expanding, what image pops into your head? Be honest. You probably picture an explosion. You picture a tiny dot of white light floating in the middle of a big, dark, empty room. And then, boom! The dot explodes. Shrapnel, stars and galaxies flies out in all directions. The shrapnel moves away from the center, flying into the empty dark space. This is the grenade model of the Big Bang. It makes perfect sense to our human brains. We understand explosions. We see them in movies. We see fireworks. They have a center, where the boom started. They have an edge, the furthest piece of debris. And they happen inside a pre-existing space. But I have to tell you something gentle but firm. That image is completely wrong. The Big Bang was not an explosion in space. It was an explosion of space. Tonight, we are going to try to visualize this together. We are going to remove the room from your mind, and we're going to learn how to have movement without a center. Let's start with a new analogy. Forget the grenade. I want you to imagine you are an ant living on the surface of a balloon, but not just any balloon, a speckled balloon. This balloon is covered in tiny dots drawn with a marker pen. Each dot is a galaxy, and you are standing on one of the dots. Let's call it the Milky Way dot. Now, imagine someone starts inflating the balloon. The rubber stretches. The balloon gets bigger. What do you see from your dot? You look at the dot next to you, Andromeda. The rubber between you and Andromeda stretches. Andromeda moves away from you. You look at a dot. Further away, the rubber between you and it stretches even more. It moves away faster. Now, here is the crucial question. Where is the center of the expansion on the surface of the balloon? Is it your dot? No. Every dot is moving away from every other dot. Is it the dot over there? No. If you hopped over to another dot, you would see exactly the same thing. You would see yourself moving away. You would see everyone else moving away. Every single point on the surface feels like the center. And because every point feels like the center, no point is the center. The center of the balloon is inside the balloon in the air. But remember, as an ant on the surface, the inside doesn't exist for you. You only know the 2D surface. In your universe, there is no center point. The expansion is happening everywhere at once. This is how our universe works. Except, we are 3D ants living in a 3D balloon. It is hard to visualize 3D rubber stretching. So let's try another analogy. Let's go to the kitchen. It is late at night. The house is quiet. Let's bake some raw raisin bread. Imagine a lump of dough. Inside the dough, you've sprinkled 100 raisins. You put the dough in the oven. The yeast activates. The dough starts to rise. It expands. It doubles in size. Now, imagine you are a raisin. You're sitting deep inside the dough. You look around. All the dough between you and your neighbors is expanding, so every neighbor is moving away from you. The raisin 1 inch away moves to 2 inches away. The raisin 10 inches away moves to 20 inches away. It looks like you are the center of the explosion. Look at that, you say. Everything is fleeing from me. I must be the most important raisin in the loaf. But then, telepathically, you talk to a raisin on the other side of the loaf. Hey, you ask, are you moving away from me? No, says the other raisin. You're moving away from me. Yes, I am the center. Everything is fleeing from me. They are both right, And they are both wrong. The expansion is a property of the dough, not the raisins. The galaxies aren't flying through space like shrapnel. They're sitting still in the dough, space. And the dough itself is swelling. This explains why we don't feel any wind. If the Earth were rushing through space at 1,000,000 miles per hour away from a central explosion, we would be crashing into gas and dust. There would be a headwind. But we don't see that. We're sitting relatively still. It is the road between the towns that is getting longer. This leads to a question that I know is bothering you. It is the question of your edge. If the balloon is getting bigger, surely it has a skin. If the loaf of bread is rising, surely it has a crust. If you are a raisin near the edge of the loaf, wouldn't you see empty oven on one side? This is where the analogy breaks down slightly, and where the infinite comes back in the bread. Analogy? Yes, there is a crust. The dough is finite. But in our universe, we've never seen a crust. Imagine the dough goes on forever. An infinite loaf of bread, infinite raisins, infinite yeast. And the whole thing, every cubic inch of it, is expanding. It stretches forever. If the universe is infinite, it can still get bigger. Wait, how can infinity get bigger? Isn't infinity already the biggest thing? Think about a ruler that goes on forever. 0, 1, 2, 3, 4, 5, to infinity. Now, stretch the ruler. Multiply every number by 2. 0, 2, 4, 6, 8, 10. The gaps between the numbers got bigger. The ruler expanded, but it is still infinite. It still has no end. It just became a less dense infinity. This is what is happening to the cosmos. The density of the universe is dropping. The galaxies are getting lonelier, but there is no centre, and there might be no edge. This brings us to the final and most difficult question of the night. What is the universe expanding? If the balloon gets bigger, it expands into the air of the room. If the bread rises, it expands into the air of the oven. Something has to be outside to make room for the inside, right? This is where you have to let go of your human intuition. You have to let go of the idea of a container. According to general relativity, the universe doesn't need a container. It is self-contained geometry. It can get bigger without taking up more space. I know, that sounds like a riddle. But think about the ruler again. When we stretched the infinite ruler, did it need extra paper to grow onto? No. It was already infinite. It just changed its internal scale. The meter became longer. The expansion of the universe is not a motion into new territory. It is a scaling up of the grid itself. The definition of distance is changing. Yesterday, the distance between us was x. Today, it is x plus 1. Not because we moved, but because the metric of reality shifted, so the answer to what is it expanding into is simple and unsatisfying. Nothing. Or even better. The question doesn't apply. Outside is a spatial concept. It implies a location, but space is created by the universe. There is no location where the universe is not. It is expanding into the future. It is expanding into itself. So, tonight, as you lie there, try to feel the expansion. It is happening right now. It is happening in the room, though the gravity of the Earth is strong enough to hold the room together so you don't notice it. But on the vast scales between the galaxies, the silence is growing. The distance to the coma cluster is bigger now than it was when you started this video. The universe is taking a deep breath, a slow, steady inhale that has lasted for 13.8 billion years, and it hasn't exhaled yet. There is something peaceful about that. We are not crashing. We're not exploding. We're just drifting apart. We are becoming more spacious. The dark is getting deeper. But if there is no center and no explosion, what is the shape of this expanding thing? If we are ants on a balloon, is the universe round? Is it flat? Is it shaped like a saddle? In the next chapter, we're going to look at the geometry of the whole. We're going to ask if the universe loops back on itself. We're going to find out if you can fly in a straight line and come home, and we're going to learn that the shape of the universe decides its fate. Will it expand forever, or will it snap back? But for now, rest in the rising dough. You're a sweet raisin in the cosmic bread, warm, safe, drifting slowly away from your troubles. We sat in the kitchen and watched the raisin bread rise. We learned that the universe is expanding. We learned that the galaxies are not flying through space like shrapnel, but that space itself is swelling like dough. And we learned that there is no center to this expansion. Every raisin feels like the center. But tonight, we have to ask the question that naturally follows. If the dough is expanding, what is the shape of the loaf? Is it round? Is it square? Is it a donut? Or does it go on forever like an infinite flat sheet? This is the question of cosmic geometry. And the answer to this question determines the ultimate fate of everything. It determines if the universe is a cozy closed room or an endless lonely plane. I want you to imagine you are an architect, but you are not designing a house. You are designing a reality. You have 3 blueprints on your desk, 3 possible shapes for the universe. Tonight we are going to look at them. We are going to test them, and then we're going to look at the real data to see which one we are actually living in. Blueprint 1. The closed universe, positive curvature. Pick up the first blueprint. This universe looks like a ball, a sphere, or, since we are in 3D, a hypersphere. In this universe, space curves back on itself. It is finite. It has a specific volume. It has a specific amount of space. But it has no edge. It has no walls. Think about the Earth again. The Earth is finite. It has a specific amount of land. But if you start walking east, and you never turn, you will never hit a wall. You will eventually arrive back where you started, coming from the west. If our universe is shaped like this, it is the Pac-Man universe. If you got in your rocket ship and flew in a straight line for long enough, you would eventually see a familiar planet ahead of you. You would see Earth. You would realize you had circumnavigated the cosmos. This universe is closed, it is cozy, and geometrically it has strange rules. In a closed universe, parallel lines eventually meet. Imagine 2 airplanes flying north from the equator. They start parallel, but at the North Pole, they crash. In a closed universe, if you shine 2 laser beams parallel into the dark, billions of years later, they will cross. And if you draw a giant triangle in the stars, the angles will add up to more than 180 degrees. The triangle will look puffed out. This is the universe that many of us want to live in. It feels contained. It feels like a jewel box. And it implies that the expansion might not last forever. If the universe is a ball, gravity might eventually win. The expansion might stop. The ball might shrink. It might end in a big crunch. Blueprint 2. The open universe. Negative curvature. Now pick up the second blueprint. This one is hard to visualize. It is shaped like a saddle or a Pringle potato chip. This is called hyperbolic geometry. In this universe, space curves away from itself. It is infinite. It goes on forever. but it is more than infinite. It flares out. In this universe, parallel lines diverge. If you shine two parallel lasers into the dark, they will spread apart. They will get further and further away from each other forever. If you draw a giant triangle in the stars, the angles will add up to less than 180 degrees. The triangle will look pinched in. This universe is lonely. It is open. It expands forever. It never stops. Gravity is too weak to hold it back. The galaxies will drift apart until they disappear. The stars will burn out. The universe will end in ice and darkness. Blueprint 3. The flat universe. Zero curvature. Now, pick up the third blueprint. This is the boring one. This is the sheet of paper, the tabletop. This is the Euclidean universe that you learned about in high school geometry. In this universe, space is not curved. It is perfectly flat. Parallel lines stay parallel forever. They never meet. They never diverge. Triangles add up to exactly 180 degrees. This universe is likely infinite. Think of a flat table that extends in all directions forever. It has no center. It has no edge. It just is. If you fly your rocket ship in this universe, you will never come back. You will never hit a wall. You will just keep finding new galaxies forever and ever. So, we have three choices. The ball, closed. The saddle, open. The sheet, flat. Which one are we in? How do we measure the shape of the universe from the inside? We can't step outside and look at it. We're the ants on the balloon. We can't see the curve. But remember the triangle. If we can draw a triangle big enough, we can measure the angles. If the angles are huge, we are in a ball. If the angles are tiny, we are in a saddle. If the angles are normal, we are on a sheet. But we need a really, really big triangle. A triangle the size of the observable universe. And incredibly, nature gave us one. The base of the triangle is the cosmic microwave background. Those hot and cold spots from the Big Bang that we see at the edge of the universe. We know exactly how big those spots should be. Physics tells us the size of the sound waves in the early plasma. So we have a ruler at the edge of the world. The apex of the triangle is Earth. You are the point of the triangle. So we look at the spots. We measure how big they look to us. If the universe is curved like a magnifying glass, positive, the spots should look huge. If the universe is curved like a shrinking lens, negative, the spots should look tiny. If the universe is flat, the spot should look exactly the size that standard geometry predicts. We built a space telescope to do this. It was called Planck. It stared at the heat of the Big Bang for years. It measured the triangle with incredible precision. And the answer is 180 degrees, to within a margin of error of 0.4%. The universe is flat. Let that sink in for a moment. We don't live in the cozy sphere. We don't live in the warped saddle. We live on the sheet. We live in a universe that follows the rules of high school geometry on the grandest scale imaginable. Parallel lines stay parallel. Lasers shot into the void stay straight. But what does this mean for the edge? What does a flat universe tell us about the size of reality? Usually flat implies infinite. If a sheet is perfectly flat and it doesn't have an edge, it has to go on forever. It implies that the global universe is an endless expanse of galaxies, or of the same, forever. This means there are infinite stars, infinite planets, and, if you follow the logic of infinity far enough, infinite versions of you. Because there are only so many ways to arrange atoms, eventually the pattern has to repeat. It is a dizzying thought, lying in your bed. You are just one instance of you in an endless hotel of rooms. However, there is one loophole, and it is my favourite loophole in all of physics. A flat universe does not guarantee that it is infinite. Think about the video game Asteroids or Pac-Man. The screen is flat. If you draw a triangle on the screen, it has 180 degrees. But if you fly off the right edge, you appear on the left. If you fly off the top, you appear on the bottom. This is a flat torus. It is a donut shape, but mathematically flat. I know, donuts look curved, but in 4D topology you can have a flat donut. Trust me on this one. It is possible that our universe is a flat torus. It is possible that it is finite, but still flat. It wraps around on itself like a giant geometric trick. If this is true, then light from the Earth could theoretically travel around the loop and come back to us. If we looked deep enough into the sky, we might see a faint ancient image of the Milky Way. We might be seeing ourselves. Scientists have looked for this. They have looked for circles in the sky, repeating patterns in the cosmic microwave background that would show the universe looping. So far, they haven't found them. We have found no evidence that the universe loops. The data points to the simplest, most terrifying answer. The universe is flat, and it is infinite. It just keeps going. The observable bubble we live in, Chapter 2, is just a drop in an endless ocean. This brings us back to the question of the edge. If the universe is infinite, it cannot have an edge. An edge implies a boundary between something and nothing, but an infinite universe is something everywhere. So, if you got in your rocket ship, you would never hit a wall. You would never loop back to Earth. You would just fly, past the first trillion galaxies, past the next trillion, through the dark ages, through the bright clusters, forever. You would run out of fuel. You would run out of time. You would run out of life, but you would never run out of universe. This creates a strange feeling in the chest, doesn't it? It is a mix of agoraphobia, fear of open spaces, and awe. We are small. We are so small. But there is a comfort here too. We're not trapped. We're not in a box. We are free. The road goes on forever. And even though we can't travel it, our minds can. We can imagine the endlessness. We can look at the ceiling of our room and know that if we could punch through it, and through the atmosphere, and through the dark, there is no ceiling to the cosmos, the lid is off. But wait, if there is no physical edge, is there a time edge? We said the universe is flat now, but was it always flat? And will it always be flat? And what about the edge of knowledge? Just because the geometry is flat doesn't mean we understand the boundary of laws. Are the laws of physics the same everywhere in this infinite sheet? Or are there bubbles of different physics floating in the infinite loaf? In the next chapter, we're going to explore the concept of a boundary that isn't a wall. We're going to talk about the difference between a spatial edge and an event horizon. We're going to learn why you can be trapped, even without walls. But for now, rest on the sheet. You are lying on a flat plane that extends to infinity. You are stable. You are level. The geometry of the universe is supporting you. In the last chapter, we laid out the blueprints of reality. We looked at the sphere, the saddle, and the sheet. We learned that the best measurements we have, from the triangle of light drawn across the ancient sky, tell us that the universe is flat. And a flat universe, unless it loops like a video game, is likely infinite. This means there is no wall. There is no signpost that says end of road. There is just more stars, more vacuum, more silence. But tonight, I want to pause. I want to challenge the very idea of an edge, because even if the universe did have an edge, what would that actually look like? Our brains are obsessed with borders. We live on continents that end at the ocean. We live in houses that end at the walls. We define objects by where they stop. A cup is a cup because it is not the table. The boundary is what gives the object its identity. So when we try to visualize the container of everything, we instinctively look for a shell. We imagine a hard physical barrier, a giant eggshell enclosing the stars, or a cliff edge where space just drops off into nothingness. But tonight, we're going to dismantle these images. We're going to learn that in physics, boundaries are almost never walls. They are transitions, they are horizons, they are limits not of matter but of possibility. Let's start with the wall. I want you to imagine you have travelled to the end of a finite universe. Let's say the universe isn't infinite. Let's say it stops. You fly your ship until you hit the barrier. Reach out your hand in your mind and touch it. What does it feel like? Is it hard? Is it cold? Is it glowing? If you can touch it, it must be made of something. It must interact with the atoms in your hand. It must have electrons pushing back against your electrons. That means the wall is made of matter or energy. And if it is made of matter or energy, then it is part of the universe. You haven't found the edge of the universe. You have just found a strange object inside the universe, a giant cosmic fence. And if it's a fence, you should be able to break it. You should be able to drill through it. And if you drill through it, what do you find on the other side? More space. If there is space on the other side to hold the fence, then the universe continues. Do you see the trap? A physical edge is a logical impossibility. You cannot build a wall out of nothing, and you cannot border everything with something. So, if there is no wall, could there be a cliff? This is the old flat earth fear, the idea that you could sail to the edge and fall off. But think about what falling means. Falling means being pulled by gravity. To fall off. The universe, you would need a giant source of gravity outside the universe to pull you down. But there is no outside, and there is no down in the void. If you flew to the edge of space, you wouldn't fall. You would just hover. You would point your flashlight into the darkness, and the beam would just go and go and go. So, we have to stop thinking of the edge as a place you can visit. Instead, we have to start thinking of the edge as a limit. In Einstein's world, the only real edges are horizons. We talked about the observable horizon in Chapter 2, the limit of what we can see. But there is another kind of horizon, a scarier one, the event horizon. This is an edge you can cross, but you can never come back from. It is a one-way door. Think about a black hole. It has an edge, the event horizon. But if you were falling into a black hole, you wouldn't see a line in the sand. You wouldn't hit a wall. You would just drift through empty space. It would feel perfectly normal. The only difference is, once you cross that invisible line, the path backward disappears. Space itself is flowing inward faster than light. The edge isn't a barrier to entry, it's a barrier to exit. Now, zoom out to the whole universe. Is there an event horizon for the cosmos? Yes, because of the expansion we talked about in Chapter 4. Remember the rising bread? Remember that the galaxies are moving away from us, and the further away they are, the faster they move. There is a specific distance, about 16 billion light-years away, where the galaxies are receding from us faster than the speed of light. Again, space can do this. The raisins can't move through the dough fast, but the dough can expand as fast as it wants. This creates a cosmic event horizon. If you were to send a signal to a galaxy past that line today, it would never reach them. Your message would travel at the speed of light, but the space between you would grow faster than the message can travel. You're running on a treadmill that is too fast, and if they sent a message to you, you would never receive it. They are cut off. They are gone. They are effectively outside your universe. This is a real edge. It is an information edge. It is not a wall you can touch. It is a curtain of silence. And the terrifying part, this curtain is squeezing in. As the universe accelerates due to dark energy, more and more galaxies are pushed across that horizon. They accelerate past the speed of light relative to us, and they vanish. One by one, the lights of the universe are blinking out. They are falling off the edge of causality. Billions of years from now, if humans are still here, the night sky will be empty. All the other galaxies will have passed the event horizon. We will be alone in a dark, stagnant pool of space. The edge will have closed in around us. This is a lonely thought. But it is better than a wall. It means the universe is dynamic. It is a living, changing geometry. But there is one final way to think about an edge, and this one is the most speculative. It is the most dreamlike. It is the edge of laws. Imagine a frozen lake. You are an ice skater. You're skating on the ice. The ice is flat. It goes on for miles. To you, the universe is ice. The laws of physics say water is hard. You can slide on it. But then you skate too far south. The temperature rises. The ice gets thin. Suddenly, the ice turns to water. You hit an edge, but it's not a wall. It's a set phase transition. The material is the same, H2O, but the state has changed. The laws of physics, how you move, how you interact, have shifted completely. You can't skate on water. You sink. Some physicists believe our universe might be like a patch of ice in a much larger ocean. This is the eternal inflation theory. It suggests that the global universe is a violently expanding chaotic energy field. But in certain spots, the energy cools down. It freezes. It forms a bubble of stability. Our universe is one of those bubbles. Inside our bubble, the laws of physics are set. Light travels at 186,000 miles per second. Protons have a certain weight. Gravity pulls. But outside our bubble, in the chaotic bulk, maybe the laws are different. Maybe light is slow. Maybe gravity pushes. Maybe there is no time. If you flew your rocket ship to the edge of our bubble, you wouldn't hit a wall. You would hit a transition. You would dissolve. Your atoms, which rely on the specific laws of our bubble to hold together, would unravel. You would become part of the chaos. This is the ultimate edge, the edge of order, the shoreline of existence. We don't know if this is true. We can't see the bubble walls, but the math of the Big Bang suggests it is possible. It suggests that we are just a tiny pocket of calm in a storm of creation. So, what does this mean for you tonight, lying in your bed? It means that the container you are looking for doesn't exist in the way you think. You're not a bird in a cage. You're a sailor on an endless sea, or a skater on an infinite sheet of ice. The only limits are the limits of light. The only walls are the walls of time. You are free. There is no ceiling to the room of reality. if you could travel fast enough, or you could go forever. But because we are human, because we are small, we crave the feeling of being held. We don't want the infinite. We want to know that we are safe in the center. And the good news is, thanks to the horizons, you are safe. You are always in the center of your own observable universe. The light from the Big Bang surrounds you like a warm blanket. The event horizon protects you from the disconnect of the deep void. You are wrapped in limits, not walls, but limits. You are held by the speed of light. You are swaddled by the laws of physics. In the next chapter, we are going to step back from the theoretical. We have talked about shapes and bubbles and infinite sheets. But what do we actually know? We're going to separate the fact from the fiction. We're going to look at the hard data, and we are going to admit what we still don't know. Because the most beautiful thing about the edge of the universe is that it is the edge of our knowledge, and that edge is always moving. So, let the walls of your imagination soften. You don't need a barrier to be safe. Gravity is holding you. The earth is carrying you, and the dark is gentle. We have been explorers of the imagination. We have flown imaginary rocket ships past the stars. We have walked on giant balloons. We have skated on infinite sheets of ice. We have talked about donuts and saddles and bubbles. It has been a beautiful journey. But tonight, we need to ground ourselves. We need to come back down from the clouds of theory and land on the solid rock of evidence. We have asked, does the universe have an edge? And we have played with the answers. Maybe it loops, or maybe it is a wall of fire, or maybe it goes on forever. But what do we actually know? If you walked into a room full of the world's smartest cosmologists and asked them to bet their lives on the shape of the universe, what would they say? Tonight, we're going to look at the map, but we're going to look at it honestly. We're going to point out the cities we have visited, and we're going to point out the vast blank spaces where we have simply written, "Here be dragons." Let's start with the hard facts, the things that are not guesses, the things that are etched in stone, or rather, in light. Fact 1. The visible edge is real. We know with absolute certainty that we live in a bubble. We've taken a picture of the wall. The cosmic microwave background. That glow from the Big Bang surrounds us in every direction. It is exactly 13.8 billion years away in time, and about 46 billion light-years away in distance. This is not a theory. It is a measurement. We are trapped in a sphere of history. We know that we cannot see past this wall, just like you cannot see past the horizon of the ocean. Fact 2. The universe is expanding. We know the raisins are moving apart. We have measured the redshift of millions of galaxies. Almost every single one is running away from us, and the ones further away are running faster. This tells us that the universe is not static. It is not a frozen painting. It is a movie, and the movie is zooming out. Fact 3. The geometry is flat. We talked about the giant triangle in the sky. We measured the angles. They add up to 180 degrees. This is a robust fact. We have measured it with balloons, with satellites, and with ground telescopes. The universe does not look like a ball to us. It does not look like a saddle. It looks like a sheet. These are the pillars of our knowledge. Based on these pillars, the standard model of cosmology says the universe is vast, flat, expanding, and possibly infinite. But now we have to talk about the cracks in the pillars. We have to talk about the things we don't know. And the biggest don't know is simply this. Why is it flat? Think about how unlikely it is for the universe to be perfectly flat. If the universe had a little bit too much matter, gravity would win and it would curl up into a ball. If it had a little bit too little matter, it would fly apart and curl into a saddle. To be flat, it has to be balanced on a knife edge. It has to have exactly the critical density of energy, not a gram more, not a gram less. It is like walking into a room and finding a pencil standing perfectly balanced on its tip. It's possible, but it's suspicious. Did someone place it there, or is there a mechanism holding it up? This mystery led scientists to invent a story called inflation. This is the leading theory for what happened before the Big Bang. It suggests that for a tiny fraction of a second, the universe didn't just expand, it blew up. It expanded exponentially. It grew from the size of an atom to the size of a grapefruit in a billionth of a second. Now, imagine an unmade bed. The sheets are wrinkled. They are curved. Now, imagine you grab the corners of the sheet and pull them apart at 1,000,000 miles an hour. You stretch the sheet. What happens to the wrinkles? They disappear. The sheet becomes tight. It becomes flat. Inflation is the stretching of the sheet. It suggests that the universe might be curved on a global scale, but because it grew so fast so early, the part we can see looks perfectly flat. We are like an ant standing on a beach ball the size of the sun. The ball is round, but to the ant, it looks like an endless flat desert. This is where science has to be humble. We measure flatness, but we suspect gigantic curvature beyond our horizon. This brings us to the edge of knowledge number 2, the topology. We said the universe is flat, but remember the Pac-Man video game? A flat screen can wrap around. We don't know if the universe wraps around. We haven't seen circles in the sky, repeating patterns yet. But if the universe is big enough, the repeating patterns might be further away than the horizon. Maybe the loop is 100 billion light-years wide. We can only see 46, so the loop is hidden from us. We can't say for sure that it doesn't loop. We can only say we haven't seen the back of our own heads yet. Edge of knowledge number 3, the outside. This is the big one. Is there anything outside our bubble? We assume yes. The principle of mediocrity says the ocean continues, but is it the same ocean? There is a theory called the multiverse, specifically eternal inflation. It suggests that our Big Bang was just a bubble forming in a much larger pot of boiling water. The pot is the bulk universe, and there are other bubbles, other universes with different laws of physics. Maybe in the next bubble over, gravity pushes instead of pulls. Maybe light is slow. Maybe atoms can't form. We have absolutely zero evidence for this. We cannot see other bubbles. We cannot touch them, but the math allows for them. So, does the universe have an edge? Maybe our bubble has an edge. The domain wall where our physics stops and the chaos begins, but we will never reach it. Because the space between the bubbles is expanding faster than light. It creates a picture of a lonely cosmos, billions of island universes drifting apart in an infinite sea, never able to touch, never able to know each other. This makes us feel small. But I want to reframe that feeling. Think about the sailors of the ancient world. Think about the Polynesians navigating the Pacific. They didn't know how big the ocean was. They didn't know if there was an edge. They just knew their boat. They knew the stars. They knew the waves. They were comfortable with the mystery. They understood that the unknown wasn't a threat. It was just room to grow. We are those sailors. We have mapped our little circle of light. We have named the currents, gravity, electromagnetism. We have measured the wind, expansion. We have spotted the shoreline of the past, the CMB. But the deep water belongs to the silence, and that is okay. A universe that we could fully explain, a universe we could put in a box and label solved, would be a boring universe. It would be a toy. We don't live in a toy. We live in a cathedral, and the roof of the cathedral is so high we can't see the ceiling. So, what does science know? It knows we're small. It knows we're young. 13.8 billion years is a blink of an eye. It knows we're seeing only a fragment of the whole. And what doesn't it know? It doesn't know the end of the story. It doesn't know if the walls are real. This leaves room for you. It leaves room for imagination. It leaves room for wonder. If the scientists haven't found the edge yet, then you are free to imagine what is out there. Maybe it's just more stars. Maybe it is a mirror. Maybe it is a void. Or maybe, just maybe, it is something entirely new. Something we haven't invented a word for yet. In the final chapter, we're going to stop trying to solve the puzzle. We're going to let the puzzle be the pillow. We're going to find peace in the fact that we are floating in an infinite open system. We're going to realize that not having an edge means we are not fenced in. We're going to close the book of physics and open the book of sleep. So, acknowledge the map, respect the blank spots, and realize that you are safe right here, in the territory you know. We have reached the final chapter of our journey. We have travelled to the ends of the earth. We have sailed past the stars. We have floated on the surface of expanding balloons and peered into the fog of the Big Bang. We started with a simple human question. Is there a wall? And we found a complex cosmic answer. No, there is just room. Tonight, we are going to leave the physics behind. We're going to put away the telescopes, fold up the maps of the microwave background, and turn off the engines of the imaginary rocket ship. We're going to return to the only place that truly matters right now. Your room, your bed, this moment. I want you to take a deep breath. Inhale the quiet of the night. Exhale the vastness of the space we just explored. Sometimes thinking about the universe can make us feel dizzy. It is called cosmic vertigo. When we realize how small we are, how brief our lives are compared to the stars, and how endless the dark really is, it can feel overwhelming. We feel like tiny specks of dust floating in a void that doesn't care about us. But tonight, in this final reflection, I want to offer you a different perspective. I want to suggest that the endlessness of the universe is not a source of fear. It is a source of peace. Think about the alternative. Imagine if we had found a wall. Imagine if the universe was a small box. Imagine if we knew everything there was to know. If we had mapped every inch. If there were no mysteries left. That would be a claustrophobic reality. It would be a prison. The fact that the universe has no edge means that we are free. It means that possibility is infinite. It means that reality is not a cage we are trapped in, but a canvas that extends forever. And even though the universe is vast, you are not lost in it. Remember the lesson of the horizon. Remember the lesson of the center. Because of the speed of light, you are always in the exact center of your own universe, no matter where you go. The bubble of light travels with you. You carry your own here and now wherever you roam. You are the anchor. So lie back and feel that anchor. Feel the gravity of the earth pulling you into the mattress. That gravity is real. It is holding you. It is connecting you to the planet. And the planet is connected to the sun. And the sun is connected to the galaxy. And the galaxy is weaving its way through the infinite sheet of space-time. You are not separate from the vastness. You are made of it. The atoms in your eyelids, the iron in your blood, the carbon in your lungs, they were all forged in stars that lived and died billions of years ago. You are the universe experiencing itself. You're the way the cosmos knows it exists. So, when you look into the dark behind your closed eyes, you're looking into the deep space of your own mind. And that inner space is just as vast and just as mysterious as the outer space now. Let's attend to the body. Let's prepare the vessel for the night. You have done the work of wondering. Now it is time to do the work of resting. Focus on your feet. Let them be heavy. Let them forget the miles they walk today. There is no edge they need to walk to. There is no boundary they need to cross. They are safe here. Focus on your hands. Let them uncurl. They don't need to hold on to anything. The universe is holding you. You don't need to steer the ship. The currents of time are carrying you gently toward tomorrow. Focus on your breath, the steady rhythm, in and out, expansion and contraction, just like the universe itself. Your lungs are a microcosm of the cosmos. With every breath, you are mimicking the Big Bang. You're taking in life, and with every exhale, you're releasing it back into the flow. Think about the silence in the room. Silence is not empty. Silence is just potential. It is the blank page before the story is written. It is the dark sky before the star is born. Rest in that potential. You don't need to solve any more riddles tonight. The question, does the universe have an edge, will still be there in the morning. The scientists will still be looking for the shape of the donut. The telescopes will still be staring at the wall of fog. But you have a more important mission. Your mission is to drift. Your mission is to cross your own event horizon, the horizon of sleep. Sleep is a lot like the edge of the universe, isn't it? It is a boundary we cross every night. We slip from the known world into the unknown. We leave the logic of the day behind and enter the dream logic of the night. We float in a sea of images and feelings. And just like the universe, our dreams seem to have no walls. They shift, they expand, they loop. So, do not be afraid to let go. Do not be afraid to fall off the edge of consciousness. You will not fall into nothingness. You will fall into restoration. You will fall into the deep repair of the mind and body. And when you wake up, the sun will be there. The earth will be there. The horizon will be waiting for you exactly where you left it. The universe is old. 13.8 billion years. It has seen countless stars burn out. It has seen galaxies collide. It is patient. It is not in a rush. And neither should you be. You have all the time in the world. Because time, as we learned, is woven into the fabric of space. And space is endless. So, close the book. Turn off the lantern. The ocean is calm tonight. The stars are watching. And you are safe in the center of the bubble. Rest in the mystery. Rest in the infinite. Rest in the quiet. Good night.